Hello teachers and friends, today we will be presenting a set of questions about projectile motion under the chapter of linear motion and forces. My name is Anqi and my group members are Yu and Yushen. In this video, we will aim to solve a projectile motion question with multiple solutions to the question with explanations and describe how the angle of shooting will affect the time reached the ground and the range between initial and final point.
The main question is, a soccer ball was kicked at an initial speed of 25 meters per second and making an angle of 45 degrees in horizontal. The diagram as shown below.
Hi, my name is Yu. Now let us start with the first question. What is the velocity of the soccer ball after 3 seconds? So before we start with the working, we can draw a simple diagram for better understanding. So draw a simple diagram, then has making an angle of 45 degrees. Then we also know that initial speed is 25 meters per second. Then we know that here is initial velocity in horizontal, which means ux. Then for uy is initial velocity in vertical. Okay, so basically we know that the first step we need to calculate for the horizontal first. So actually for initial velocity in horizontal also equal to final velocity in horizontal, because that it just like move in horizontal, it didn't like move anywhere, so it's the same. After that is 25 plus 45. We use plus because the angle is in between. If it's in opposite, we use sin. Okay, so this one is just for the extra information. Then 25 cos 45, which is equal to 17.68 meter per second. Okay, so we already solved for the final velocity in horizontal. Now we solve for the final velocity in vertical. So how do we solve with the final velocity in vertical? So firstly, according to the formula, we know that we must use the initial velocity in vertical plus with gravitational and then times with time. So now for the initial velocity in vertical is 25 sin 45. So we use sin because just now we said already is in opposite. The angle is at here. So now you need to calculate for vertical. That means like the angle and the vertical way is already opposite, so we use sin. So plus with gravitational acceleration negative 9.81. We use negative because the ball is moved upward. It's already opposite with the gravitational acceleration, so we use negative. Then times with time 3 seconds. So it's equal to negative 11.75 meter per second. Okay, so now we know already. Okay, now let's imagine it's a triangle. Then we have information that here is 45. Then for the velocity in horizontal is 17.68. Then the velocity in vertical is negative 11.75. Now we just calculate for this and this only. So that means like the longest line is velocity. So we want to calculate for the longest part, we must use the Pythagoras theorem to calculate. So velocity actually is also equal to resultant velocity. So how we calculate for the resultant velocity is use the Pythagoras theorem formula. 70.68 square plus negative 11.75 square and then square root. So continue with the calculations. 450.64 and then square root. And then equal to 21.23 meter per second. So because of the significant figure is 3 significant figures, so we round up 21.2 meter per second. So we already calculate for the answer. Then now have another way is, basically it is have another formula for the velocity in vertical. This means this part. You can also use another formula, which is initial velocity square plus 2 times gravitational acceleration times t square. So also same, 25 sin 45 square plus 2 times negative 9.81 and then 3 seconds square. So, sorry, here has a square. Okay. Then after that, so it's 312.5 and minus 176.8 and then square root. So at last, the velocity in vertical is 11.66 meter per second. Then also continue with the same. Also can imagine as a triangle. Same thing, also 17.68 in horizontal. Then for here is 11.66. So here is also 45 degrees. So for the velocity is equal to resultant velocity. It's the same way in Pythagoras theorem. So it's equal to 17.68 square plus 11.66 square and then square root. So the answer is 21.17 meter per second. And then because of 3 significant figures, so it's 21.2 meter per second. So you can see the answer is the same. So it's different is the way we calculate final velocity in vertical is have two formulas. One is Vy equals to Uy plus G times 50. Then another equation is Vy squared equals to Uy squared plus 2 times gravitational acceleration times with time squared. Yeah, that's all from me now. Next question will be my partner's turn, who is Anqi.
The question asks, what is the maximum height the ball can reach? For this question, I will present and explain two methods. We can use a diagram to help us visualize this question. From the question, we are able to get the initial speed, u, which is 25 meters per second. For the first step, we should determine the horizontal and vertical component of the ball. Horizontal component is not affected by gravity, as gravity only acts downwards. Therefore, it does not affect height, assuming that air resistance is ignored in this question. Because of that, horizontal component is not used to calculate the speed of the ball. Vertical component affects the maximum height reachable, as it is affected by gravity. For the vertical component, we can use the formula u sine theta. U is initial speed, so it will be 25 times sine our angle, which is 45. From this, we get that our vertical component is 17.68. After that, we use an equation of motion, also known as Suvat equation, which connects displacement, initial and final speed, acceleration, and time. Vy, the final speed, is 0 because at maximum height the ball is not moving. For that moment, its velocity is 0. After rearranging the equation, we can calculate the maximum height by dividing u squared over 2 times of g, which brings us to the final answer, 15.9 meters. This concludes method 1. We are able to use the formula for kinetic energy, which is half of mv squared, where m represents mass of the object and v represents velocity. Despite not having mass in this question, you will see later on why we choose to use this formula. When the ball is kicked and reaches its maximum height, kinetic energy is converted to gravitational potential energy, as the ball is not moving. Because of that, we can say that at its maximum height, kinetic energy is equal to gravitational potential energy. We write the formula in this way. Mass is cancelled out of the equation, and we can rearrange it to form the same equation as method 1. After plugging in the numbers, we get 15.9.
So now is the last question. If the soccer ball were kicked with the same initial speed, but with the angle of 60 degrees instead of 45 degrees, show the calculations and explain which angle gives the greater range. So for these questions, we need to find two things. One is time and range for both different angles. So these questions, we need to use linear motion formula, which is final velocity equals to initial velocity plus at. We replace the a equals to g because we assume that air resistance is negligible. Yeah, so we replace the a by g, so sub in the value to the formula, and then we need to times 2 with the seconds is because the time of the ball reaches the maximum and then falling back down to the ground. So the both of the time is same. So we need to times 2. And then we find the range and then sub in the value to the formula. And then later you will get the answer, which is 63.72 meter. Round it up become 63.7 meter. So now it's 60 degrees. We also need to find the ball, the time of the ball reaching the ground. So using the linear motion formula, now is uy, which is vertically, using sine, which is 25 sine 60. Find the answer. Sub into the linear motion formula. Find a t. And then later you need to times 2 again because the ball reaches to the time of the ball reaches the maximum height and then falling back down to it again. So it's twice. So you will get the final answer of the time is 4.404 seconds. And then you find the range. Then the range formula is r equals to initial times time. And then now it's ux, which is cos 25 cos 60. You find the answer, sub into the range formula, and then you will get the final answer is 55 meters. So now this is time for explanation. So the time of the flight depends on the vertical velocity. a larger vertical velocity to keep the projectile in the air longer. On the other hand, the horizontal velocity determines how far the projectile travels during the time. So now we are doing the projectile motion experiment. We can see that the 45 degree have the greater range compared to the 60 degree. It is because the range formula is r equals to u squared sine 2 theta over g. So from this equation, the range depends on the sine 2 theta. The maximum value of the sine function is 1, and that happens when 2 theta equals to 90 degree. So we want to find the theta, we move the 2 to another side, so it's 90 divided by 2, which is 45 degree. And at this angle, the horizontal and vertical components of the velocity are perfectly balanced given the maximum range. That's all from us. Thank you everyone. So remember to like, subscribe, and share to your friends. Yeah, see you guys. Bye bye.